Hey everyone, and welcome back to this class, Deep Reinforcement Learning, Deep Learning in Python Part 7. In this lecture, we are going to summarize everything we learned in this section. This section was all about introducing you to the OpenAI gym and then getting you to build gradually more and more complex reinforcement learning agents using what you already know. First, we started by looking at the OpenAI gym interface. We saw how we could grab any environment, look at its state space, look at its action space, and play any episode. We saw how we could save a video of our agent playing an episode. The first algorithm we looked at was random search for carpool. Random search is easy to conceptualize because it doesn't require any complicated math. Instead, we just keep choosing random weight vectors until we find a setting that's good. Next, we looked at carpool again, but using Q-learning with binned states. Using binned states allowed us to use the tabular method, which you're familiar with from the last course. This example also helped reacquaint you with Q-learning, which is a simple TD0 method we reviewed earlier. After that, I introduced you to RBF networks. RBF networks are historically interesting because they are related to both support vector machines and neural networks. In particular, they allowed us to use a neural network with nonlinear features, but to still keep using a linear gradient descent algorithm. We saw that the other perspective of this model is that the RBFs are doing a feature expansion, and all we're doing is applying linear regression on top of that. We then looked at the mountain car task with Q-learning and RBF networks. This is the first time we used an approximation method in this course. Doing this example allowed us to learn about some important implementation details, like choosing RBF exemplars, combining features, and other scikit-learn tools. We then applied Q-learning with RBF networks to the carpool task. We saw that we had to make some modifications because carpool's state space extends to infinity, and OpenAI gym samples uniformly from this state space, without regard to the probability that you'd end up in any particular state. We know that these won't give us good exemplars for our RBFs. In this example, we took the next step and built our own linear function approximator with gradient descent in NumPy. Next, we did a warm-up in Theano, where we took the previous code and rewrote the linear function approximator in Theano. This allowed us to reacquaint ourselves with important Theano features, like creating shared variables, data variables, update equations, and Theano functions. Next, we did the same warm-up in TensorFlow, where we rewrote the function approximator again. This allowed us to reacquaint ourselves with important TensorFlow features, like creating variables, placeholders, sessions, and optimizers.